Alrighty, welcome everyone to day 9 of Advent to Code. Yeah, as you can see, I've missed a few days, 6, 7, 8 here. Yeah, I was out of town. I am pretty mentally drained. I didn't get due today 8 last night like I was hoping to. Fell asleep. We're gonna see how day 9 goes. I know it's probably much harder than when we left off on day 5. Solid chance I can't finish it. Again, mental capacity is a premium for me right now, but I'm here to give it as best of a shot as I can. Obviously, watching after the fact, the videos are already kind of be fixed and figured out. But anyways, day 9, you slide down the fire pole in the corner of the playground and land in the North Pole base. Again, the story doesn't make no sense to me because I've missed the days. The movie theater has a big tile floor with the interesting pattern. Elves are decorating the theater by switching out some of the square tiles in a big grid form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for 2 of its opposite corners. They even have a list of where the red tiles are located in the grid, your puzzle input. For example, our grid, show the red tiles as the hash and the other tiles as a dot. The above range of red tiles look like this. Your goal is to choose any 2 red tiles as the opposite corners of your rectangle. Your goal is to find the largest rectangle possible. This should be pretty simple as we're just doing Manhattan distance, right? It's just Manhattan distance between, but it's got to be doing every position. Oof. And it's going to be this giant, this is this nice giant, alright, anyways, day 9, let's put this in. It's easy because they're just going to be all points, so we can actually just go ahead and just do a list. Actually, let's do fancy. You know what? Let's get fancy today. Input, we're going to map this, jeez. We're going to do some functional Java here. And align is going to return a new point. Is it? It's just point. Why is it not? Okay, anyways. And so we're gonna have to do quick string parts here, as we are going to break this line up on, I believe it's commas. Yes, commas. Cool. And we're just gonna go integer parse int, and it's going to be parts, and we're actually going to have to do 1 first because again my points are row column, not xy, so that's why I'm doing 1 as the y instead of the x first. And this will give us a list of points. Again, just doing functional just for fun. I gotta make it to list. There we go. Okay. So we have our points. So obviously we can just go and iterate through them all. How many are there? There's only 500, like just under 500. I mean, we can brute force it. How badly is this going to screw us over for part 2? All right, fine, brute forcing. What's it just asking? It's just asking for the area. Yeah. All right. Brute forcing. Let's see. Just get it done. Just get her done. We're gonna do it this way because I like this way better. Int I equals 0. Y is less than points dot size. It's not JavaScript, not TypeScript. I plus plus. And then we're gonna do this again, but we're gonna make this J, and it's gonna go from J to J starting at I, and do it this way. So. Point P1, actually I'm going to call point P1 up here. It's going to equal to points get I, P2 is J, and now we're just going to get the, I'll make it long, is going to be equal to P1 math dot absolute of P1 dot row minus P2 dot row, multiplying by this, just get the columns, and literally that's it. This is going to get our area. I'm going to just do a simple check if I should just call this part 1. If part 1 is greater than area, other way around, if area is greater than part 1, Part 1 equals area. Cool. Is it because this is going to give me... Oh no, absolute's only integers. Okay, I think we go with integers then. If it's going to cast it anyways, there's no point to make it like that. And down here I can just do a lap of part 1. And in theory, that's part 1. That number seems weird to me. Maybe I do need to make these longs. Is that gonna... Yeah, okay. I was about to say that looks really... That looks like kind of like a max int type deal to me. I can wait 20 more seconds. Okay. Okay, we should be good now. It's still not right? Bro, what? $36. Area 50. Interesting. What? What am I doing? I must have a simple mistake here somewhere. Actually, it's I+1, by the way. I can change it. What am I doing wrong? Let me just do a system out print line. So I gotta be doing something silly here. What was the examples? 24, 25 to 97. They're backwards, so it's actually gonna give me 97 to 25. 14. What? 2 times 7. Oh, am I forgetting to add 1? Oh. I need to add 1 to these. Gotcha. Ah, off by 1 errors. I love to see it. Love to see it. Yeah, it's sick. Cool. Alright, now we should be good. Nice, simple off by 1 error. Of course, of course. Alright, now how badly am I screwed over with part 2? The users remembered they can only switch out tiles that are red or green, so your rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps so the first red tile is also connected to the last red tile. The tiles are adjacent in your list will always be on either the same row or same column. Using the same examples before, the tiles marked to be green. In addition, all the tiles inside the loop of red and green tiles are also green. Green tiles are never red nor green. The rectangle you choose the rectangle you choose still must have red tiles in opposite corners. But any other tiles it includes must now be red or green. What? It's the same thing. What's changed? Oh, it must be inside. Oh, it must be within. I got it. Okay, okay. It has to be within this rectangle here. All right. So, So the way I want to do it, or would we solve it, is basically we would make this shape be a polygon. And what we would do is we would go through basically the same exact process we did, but we would check to make sure all four corners were within the polygon, which wouldn't work for concave. Oh no. I don't want to iterate over all of the points inside of it. Oh. I mean, it could just be to make sure. It's just making sure that our square is always, our rectangle is always within the polygon. Which means, wait, we can do this. We just need to make sure that none of the lines or none of the edges of our rectangle pass through the edge of our polygon. Okay, I think I've done some more thinking, and I think it's using the lines for intersecting isn't going to work for more complex things. Like, maybe my input doesn't have the more complex things I'm thinking of, but I don't think what I'm doing intersections work. I think what I needed to do is basically I need to form the polygon, and I need to check that every point on the edge of the rectangles we make are within the polygon. If every point is in the polygon, then that will work. Or every point on the edge of the rectangle is within the polygon. I think that's what I need to do. And right now I can't think of a way to check if a point is within the polygon, because it gets complex with, again, concave, convex, from which way it is. But yeah, I mean, there's a way. I mean, obviously, there's a way you can. The way you can tell if a point is within is first if it lies on a line. That's easy. The other way to do is basically you take a point and you fire a ray in every direction. Luckily, it's only 4 directions, but you would fire a ray and you would see how many times that ray passes through a line on the polygon. So again, it gets back to line, intersecting line, yeah. But what happens is when you fire that ray through, if it passes through an odd number of times, your point lies within the polygon. If it passes through an even number of times, you lie outside the polygon. So I could build this method to go through every point from the minimum to the maximum in our range, and determine if they're within the polygon or not. It would work. I think I'm gonna call it there. I think that's the solution. So if you're trying to do it, that would be your code solution. Basically, you form again this line. I don't even think you need. I guess the lines, it just makes the mic a little bit easier. But basically, you would take every point, you would have your lines for your polygon, and then you would go through basically your same as your part 1. And then for part 2, you would just, you would build your lines, your edges of your rectangle. And then for every point on the edge of your rectangle, you would just do that check of fire array in all 4 directions and see, what's the number of times you pass through your polygon. If it's obviously 0, it's outside. If it's 1, 3, 5, or whatever, you're within your polygon. If it's any even number, you're without. And if any direction, you fire and it's, giving you an even number, that's what I was trying to think. It gives you an even number, obviously, then your rectangle is not valid. It's not within the polygon. And obviously, because you have your lines, whether or not a point lies on a line. That's easy enough to check. So you would just check for within that way. So yeah, I don't think I have the time to try. I mean, You know what? I might try. Well, okay. If there's something right after this of me giving you, say, hey, I did it. I did try. If not, then I didn't. So I guess we'll cut to fancy transition. Well, I got close. Not really. I don't know. My code devolved. I don't know. I gave it a shot, but no, still didn't get it. So, anyways, yeah, day 9. Woo, so successful. See you guys tomorrow, day 10. Yeah.